So we are talking about, today we are talking about negative exponents. What does it mean? Lodikshita.
Hi, sir.
What does negative exponent mean? Hello Suhina.
Hi, sir.
Suhina was missed in the class yesterday. Yeah?
Yeah, I went out.
Yeah. I know you guys are having fun and I'm the one who's bothering everybody during Thanksgiving break also. But I promise, we'll not have class next weekend, okay? So you guys can feel little relieved and not, oh, Arav is already crying for not having a class next week. You guys, you love me so much. I didn't know that. I'm just kidding. Alright. So, we'll talk about negative exponents. If I talk about 3 to the power 2, Ariyahi, come on in, beta. And Ariyahi, I'm giving you one task. Knock the door and ask Myra to join.
Okay.
Come with you in the classroom.
Like, go in?
Yeah, should be. Hello Milana, how are you? Good. Okay. Myra, you are not joining online. You are coming to the classroom along with Ariyahi. I want to see you in the classroom.
Oh, what's your name?
Yeah, come over. Okay? So we are going to talk about negative exponents. And what does it mean is what we will see today. If I say 3 to the power 2, I am talking about 3 into 3. If I say 4 to the power 3, I am talking about 4 into 4 into 4. Go ahead. Okay. What do I mean by 2 to the power minus 5?
Master.
What do I mean by something to the power minus 5? Rolaksh. Hello Gayatri.
Hi, sir.
Hello Beta. So, I should have taken 2 weeks break due to Thanksgiving. I did not do that. And I'm working hard on a weekend to explain to you guys. So I thought of taking revenge. That's why I'm trying to bother you guys, saying, if you know something to the power 2, something square is something into some same thing. How about a power which is negative? What does it mean to us? Yes, Arav.
It means that like the numbers will be repetitive, but it'll be negative. So like negative 5, no, negative 2 times negative 2, 5 times.
Sure. Sammy, what do you think?
Sir, I think it's like going to be 2 times, or negative 2 times negative 2 times negative 2 times negative 2 times negative 2.
Okay, Nihan. Abhi, what do you think? So, Radhya. So for all the kids, right? I'm trying to bother you guys with a problem like this. We are going to learn about negative exponents today. So if I say 3 to the power 2, I'm talking about 3 into 3, 3 being multiplied with itself 2 times. I'll come to you, Laksh, okay? 4 to the power 3 means 4 into 4 into 4. Now I'm talking about 2 to the power minus 5. What does it mean? Yes, Laksh, go ahead. I'll come to you.
Isn't it a clear decimal and how many zeros is the exponent, negative exponent? So, for example, of 2 to the power of negative 5, then you would put a 0 point and then 5 zeros and then 2.
Mm-hmm. Yes, Byra, you were saying something.
Must have been Ariyahi can leave like 10 minutes early.
That's okay. You first answer the question.
What was the question?
Question is, how much, if I say something is squared, I'm talking about this into this. If I'm saying something cube, I'm talking about this into this into this. If I'm talking something about minus 2, minus 4, minus 6, what do I mean by that? So, Saturday and Suleem, there's a horror show going on. I'm torturing everybody right now. Nobody is giving any creative answer for this. Gayatri, any idea, beta?
Can you repeat the question?
I'm saying, what do I mean by something to the power negative 5 or negative 4 or negative 2? If I had a power, something to the power 3 means this into this into this 3 times. But if I have negative power, what do I mean by that? Yes, Deekshita.
It means that the number it's getting multiplied by negative 2 5 times.
Nihan.
So you're gonna multiply negative five times with the 2, and using the formula like negative times say positive.
No, I will not let you proceed there. You're in the wrong direction. Advik.
You have to turn 2 into a fraction, so it's 1 over 2 by the power of 5.
Nope. Alright. Sandy and Celine, what do you think? I'm not trying to put anybody on the spot. I'm just trying to make sure that if somebody has this information, my job becomes easier. I can just borrow that concept from you guys and just repeat or package that in my own way. Yes, Abhi.
So, I'm not sure with it. Like, what do you do like a fraction, then like you do it on 2 to the power of 5, and then now you can open it.
I could barely hear you, Abhi. You might be talking from a distance or there's something wrong with the mic. Can you be a little louder for me?
You do it 2 to the power of 5, and then you get into 32, you make that 32 over 1.
No. Sandy and Celine, I'm waiting for you and Sanvita. What do you think, Beta?
Could you repeat the question again?
I have a number to the power minus 5. What does it mean to us? If I had a number, if I had a number to the power 3, that meant this number times this number times this number. If I had a number to the power 5, that meant that number times that number times that number 5 times. But I have a number to the power negative. What does it mean to me? Any idea? Or something new?
It's like 1 over 2 to the power 5.
Okay. Sanvita has given me one point of view. How about Milana? Go ahead.
It means that you multiply by the number, except the answer is gonna be negative.
Nope. Sandy Lane, you were saying something.
I think you divide it by 1, and then it's 1 over 2 to the power of 5.
Okay. So you guys, Sanvita and Sandy Lane has given me, they have given me the answer that if you have any, okay, so Myra, I need one help from you. Can you close the garage door so that the AC is more, the heater is more effective. It will start getting cold. So now as you guys can see, right, this is what I was trying to steal the idea from you guys and then package it and present in a very glorified way in front of you guys. That's what I did. So Sanvita and Sandy and Sunil, they told me that if I have something to the power, let's say minus 3, it will be 1 over 2 to the power 3. If I have Myra and Nariyahi here, 5 to the power minus 2, that would mean 1 over 5 to the power 2. Meaning, if I have negative power, I can move it from numerator to denominator and flip the power from a negative to positive. And I assume Sandy Celine and Sanvita knows why, but I will still let them tell me the story. How? Who wants to go first? Sanvita, you want to explain this?
Well, because it would be the same as like 1 over x times itself 5 times.
Okay, Sandy Celine, any interesting story that you want to say, better? Okay, so this, did I teach you guys the exponent rules in the class? Do you guys remember what are those exponent rules that we talked about in the past? Exponent rules. Let me repeat myself. If you are talking about exponent rules, there are 3 rules. Yes. So Lach, you're saying something?
Yeah, I remember the exponent rules.
So now hold it. Now it's my turn. Okay. Sarvita, you were saying something? Adding something to what you said?
No, I
No.
was going to do the exponent rules too.
Exactly. So now it's my turn. So there are 3 exponent rules. If you guys remember, if you have seen me do it before. If I have x to the power a times x to the power b, that will become x to the power a plus b. Meaning, if I have 2 exponents, okay, with the same base, and when I multiply them, their power will get added. If you want to see it in real life, if I have 2 to the power 3 into 2 to the power 1, this will become 2 to the power 3 plus 1. That will be 2 to the power 4. How? You can see it right in front of your eyes. 2 to the power 3 is 2 into 2 into 2, and then you multiply by 2 to the power 1, that is 2. How many 2's you are seeing here? 2, 4 times 2. 2 into 2 4 times. That is 2 to the power 4. So basically, simple rule of thumb is, if you have any 2 exponent that you are multiplying which have the same base, the power gets added. Sure? Everybody okay? Dana okay? Hiranya okay? Okay. Now, this is the first rule of exponent, which says, if you have any 2 exponents with the same base, when you multiply them, the power gets added. Second rule of exponent says this: x to the power a divided by x to the power b equals x to the power a minus b. Meaning, if you are trying to divide one exponent by another one and both have the same base, the power of the denominator gets subtracted from the power of the numerator. Look at it. 2 to the power 5 divided by 2 to the power 3. If we believe this rule, then it will become 2 to the power 5 minus 3. That is 2 to the power 5 minus 3 is 2. 2 to the power 2. Yeah? Everybody here. So now let's look at it. 2 to the power 5 is what? 2 into 2 into 2 into 2 into 2 5 times. 2 to the power 3 is 2 into 2 into 2. Time to play. Tic-tac-toe. This 2 and this 2 tic-tac-toe. This 2 and this 2 tic-tac-toe. What we are left with? 2 to the power 2. Which is same as 2 to the power 5 minus 3. So this is the second rule of exponent. Are you guys with me so far? So when I was asking you guys,
So can you explain that again? I just like it.
okay, let's say, let me not use 2 this time. If I say 3 to the power 2 into 3 to the power 3, how much that will be? 3 to the power 5, meaning I have 2 exponents with the same base. This is my base and these are the powers, okay? So when I multiply 2 exponents with the same base, their power get added. It becomes 3 to the power 5. And you can do it yourself also. 3 to the power 3. My grand, Arya here. 3 to the power 3 is nothing but 3 into 3 into 3, 3 times. Times 3 to the power, sorry, this is 3 to the power 2. That is 3 into 3, 2 times. And then multiplied by 3 to the power 3, that is 3 into 3 into 3, 3 times. How many 3's you see? 5. It gets added, yes.
So if they aren't the same base, would we multiply them regularly?
No, you will not treat them same. So 2 to the power 2 and 4 to the power 7, if I have to multiply, I will not multiply these two. For me, these two are 2 different creatures. I don't recognize them as one. So you will only deal with them applying any of the exponent rule if and only if your bases are the same.
Okay.
If they are not, they are different animals altogether. Yeah? See, Swami is happy. I'm not talking about fruit, I'm talking about animal now. Yeah? Okay. So here, So this is the first rule which says if you are multiplying two exponents which have same base, your power gets added. That part okay, Sami? Suhina okay with that? Milana okay with that? And the second rule of exponent says if you are dividing one exponent by another exponent and both have the same base, your power of the denominator gets subtracted from the power of the numerator. So x by a to the power x by b becomes x to the power a minus b. Yeah? And for Sami, Suhina, Milana, Myra, Riyahi, Shandin, Sulaim, Tasvik, everybody to believe. I know Lars already believes that, he has seen it before. So for everybody to believe, I mean the names that I called I did not mean that you guys don't understand it. I was just random with some name selection, okay? So what this means to me is, if I have 4 to the power 6 divided by 4 to the power 2, how much that would be? As per this rule, it will be, I have both exponents with the same base, so I will subtract 2 from 6, it will become 4 to the power 6 minus 2. That will be 4 to the power 6 minus 2, which will be equal to 4 to the power 4. Yeah? But let's see it. 4 to the power 6, that is 4 to 4 into 4 into 4 into 4. 6 times. Divided by 4 to the power 2. Meaning 4 into 4. Tic-tac-toe. This one, tic-tac-toe. How many 4s we are left with? 4 4s. That will be equal to 4 to the power 4. Isn't the same as this one? Yeah? So this is the second rule of exponent. I'm not going to talk about the third one right now. Because we can deal with these two for now. So, now these are the two rules. Rule number 1, if I am multiplying one exponent with another exponent and both have the same base, the power gets added. Rule number 2 says, if I am dividing one exponent by another exponent and the bases are the same, the power of the denominator gets subtracted from the power of the numerator. Now, I didn't want to do the class today. Somebody forced me to do the class. No, I'm just kidding. I'm just kidding. So what I was trying to tell was, I am trying to bother you guys. No, I'm not trying to bother you guys, okay? Why would I bother you guys? What I'm doing actually is, whatever rule that we have, I'm flipping it. Meaning, I'm writing in the reverse order. I can say this, x to the power a minus b equals x to the power a divided by x to the power b. Is it okay to say so? I wrote here, this whole thing equal to this, so I'm reversing it and saying, okay, this thing is equal to this. That is okay? So, this is what Sanmita and Sandy and Sulin were trying to do, okay? I have just stolen their ideas and I'm showing it here as my credit, okay? Let's say, if I'm talking about 5 to the power minus 2, what does it mean? Sanvita, Sandy and Sulin told that it will become 1 over 5 to the power 2, meaning you will move this whole thing from numerator to denominator and flip the power from positive to negative. That's what they said. And how this works is like this. 5 to the power minus 2, is it okay for me to write this as 5 to the power 0 minus 2? Yeah? Can I write 5 to the power minus 2 as 5 to the power 0 minus 2? No? Lux doesn't agree with me? Yes, Sami?
Yeah, you can write it as
Minus 2 is 0 minus 2. Minus 5 is 0 minus 5. Minus 10 is 0 minus 10.
yeah.
I had 0, I subtracted 10 from it. That's how I got minus 10.
Yeah.
Yeah? Lux, does it make sense? Gayatri, is it okay with her?
Yes, sir.
Sauria, no argument? No contention? Yeah? You agree with me, right?
Yeah.
Yeah. So if I had something to the power minus, that is as good as something to the power 0 minus that number. Okay? So now look at it. Look at this number. 5 to the, okay, clean it up a little bit. 5 to the power 0 minus 2. Look at this number. I mean, stare at this number. and then stare this formula. Do you see some similarity? I have something to the power 0 minus 2, something to the power something minus something equals something to the power this divided by something to the power this. If you look at this number here and look at this formula here, you can relate this using this. Meaning if you have something to the power a minus b, that equals something to the power a divided by something to the power b, as you can see here. So this 0 minus 2 situation, I am using this thing to relate. So I will say, relating with the second rule of exponent, I can write this as 5 to the power 0 divided by 5 to the power 2. Look at this, look at this. Take your sweet 30, 40, 45, 47, 48 seconds to digest and process this before I move ahead. If it doesn't make sense, you have all the reasons to ask me why. Yes, Sohina.
Can you explain both again so I can understand it?
Okay. So Aradhya, Sohina, Milana, Sanvita, everybody, okay? Tasve. This is my second rule of exponent, okay? Which says something to the power a divided by something to the power b, meaning the base are same, will be equal to something to the power a minus b. Maya and Ariyahi, do you see this thing? Do you agree with this one?
Yeah.
So if I have something to the power a divided by something to the power b equals something to the power a minus b. This is the second rule of exponent. I am flipping it and reading it in the reverse order. So I am saying something to the power a minus b equals something to the power a divided by something to the power b. Yeah, as you can see here. Now when I had 5 to the power minus 2, I said, oh, minus 2. I don't know what does minus 2 mean. So I can say that as 5 to the power 0 minus 2. Now I have two numbers. Yeah? Minus 2 I can write as 0 minus 2. Minus 3 I can write as 0 minus 3. Minus 5 I can write as 0 minus 5. Yeah? So you know, agree? So when I change this 5 to the power minus 2 as 5 to the power 0 minus 2, then I have a reason to compare it with this guy. See, this guy says something to the power a minus b, something to the power a minus b equals something to the power a, something to the power a, something to the power, my a is 0 here, my b is 2 here. So something to the power a divided by something to the power b. Yeah? Digestible? Or anybody is needing Hajmola right now to digest this? Everybody knows what is Hajmola, right? You use Hajmola for digesting when you overeat. So I am hoping that this is acceptable. Yeah? Gayatri, okay with that? Abhi, okay? So now, what is happening is 5 to the power minus 2 became 5 to the power 0 divided by 5 to the power 2. What does 5 to the power 0 mean? A 1. Yes, Sohina, agree? So 5 to the power 0 is 1. Look at this whole journey. You had something to the power minus 2 that became this. So this thing moved from numerator to denominator, and power of this changed from minus 2 to plus 2. So this is how it travels. Tomorrow if I say 7 to the power minus 4, you will not even think about it. You will say, okay, fine, I just move it below and I'm fine. Okay? If I say 1 over 2 to the power 2, okay, you will say I can just move it up and it flips its power from positive to negative. So basically it's all, the deal is about moving it from numerator to denominator, denominator to numerator. Your power just flips from positive to negative, that's it. Yes or no? Yeah? Tasvik, okay?
Okay.
Gayatri, Abhi, Advik, Arav, Aradhya, okay? Okay. So, this is all about the negative exponent. If you ask me was there more I had for teaching you guys? No, I'm running out of content. I don't have enough. This is the only thing that you need to be aware of when it comes to negative exponent. Meaning, forget about all this thing. Now, this should be part of your muscle memory. Okay? If you are being asked to solve a problem like this, then okay, find out 7 to the power minus 1. Oh, yeah.
How would we like figure it out, like how to solve it if it's like a problem? Or
What?
will it come in a word problem?
If it comes in a word problem, it will still give you something like inverse or 1 over this thing or power negative. So you will be able to, basically when you read a word problem, you will know what number is talking about, right? You will see that number represented in some form. You will see if it is not written like this, then you would hear something like to the power negative or inverse. Something will give you that clue that you're talking about a power which is not positive.
Okay.
Yeah? If you see something like this, I'm saying this should be part of your muscle memory. If I have negative power, I will not even think about it, I'll just move it below. That's it. To the power 1, or which is same as 1 by 7. If you see 3.5 to the power 2.5, what do I do? Don't worry about it. But if you see 3.5 to the power minus 2.5, again you will not worry about it. It's a minus power. It is as good as 1 over that number. Now how to find out these things, that we'll come talk about it. First thing first is, how do you take care of the negative sign? Be it in the numerator or denominator. When you make it move up or down, that should be it. Now let me show you guys some problem. And that will make life a little easier, okay? Though I was trying to show you guys a horror movie, it turned out to be a comedy show. Yeah? So, if I have 2 to the power minus 4 into 3 to the power minus 2 divided by 3 to the power minus 3 into 2 to the power 1. If I had to deal with this, I had 2 to the power minus 4, 3 to the power minus 2, 3 to the power minus 3, 2 to the power 1. If I had a situation like this, my first go would be, how do I take care of negative powers? Because that gets me a little confused. But we have a magic wand which says, you move from here to here, power changes to positive. You move from here to above, power changes to positive. So when you move from numerator to denominator, power will change its sign or vice versa, both ways. So this guy is here, is not better off, okay? This guy is negative, I don't like it. So I will move this guy below. This became 2 to the power 4. This guy is taken care. Here also this guy has minus 2 power, I don't like it. I'll move this guy below. And this also became a positive power. These two numbers are taken care. I'll look at this guy. This guy also has a negative power, I don't like it. I'll make it go up. Power changes to positive. Then I have 2 to the power 1. I love this guy. Fine. Now, life looks much easier, much better, much more amiable, right? We know how to deal with these kind of things. Now you will see, okay, I have 3 to the power 3 and 3 to the power 2. You have two options here. You will say, let me simplify it. 3 to the power 3 is 3 into 3 into 3. Divided by 2 to the power 4 is 2 into 2 into 2 into 2, 4 times. And then 3 to the power 2 is 3 into 3. And then I have a 2. Let's do tic-tac-toe. This gone, this gone. And then this. So this I can write in the exponent form. I can write this as 3 divided by how many 2's I have? 1, 2, 3, 4, 5. 2 to the power 5. This is one way of doing it. Simplest possible way. Or you can leverage your knowledge of exponents to solve this. Myra, can you focus here? No, whatever you're doing, just stop there. During the class, I want everybody to have full attention in the class. Now, when I have this, I can leverage my knowledge of exponents also. Let's look at it. This was a simpler way, the tic-tac way, the playful way. And we can also use the knowledge of exponents. Here, see, this is 3 power 3 and this is 3 power 2. I can bring all the 3's together. I can bring all the 2's together. So when I move this guy from here to here, this will become 3 to the power minus 2. All the 3's are together now. And 2 to the power 4 into 2. When I multiply two exponents, the power gets added. So what will happen here? 3 to the power 3 plus minus 2. I'm adding 3 and minus 2. When I'm looking at this guy, both have the same base, power will get added. 2 to the power 4 plus 1. So this became 3 plus minus 2. How much that would be? Yep.
3 plus minus 2 would be 1.
1, right? 3 plus minus 2, that becomes 3 power 1. And 2 to the power 4 plus 1 becomes 2 power 5, not 25. It became 3 to the power 1 by 2 to the power 5. Yeah? Yeah.
Can we also write that as 3 to the power 3 over 2 to the power 5? Because 3.
Yeah. 3, no, this is not 3 power 3, this is 3 power 1, right?
Yeah,
Like you
that's what
said.
I'm saying. So can we write it 3 and then, like.
3 by 3 power 5, yeah? 3 power 1 is 3, yeah. Anything power 1 is that number, okay? So, again, what I was saying was, when we were dealing with a situation like this, the first thing we did was, we simplified it. We did not like the negative power, that was kind of getting a little confusing. So we kind of got rid of the negative powers and moved the numbers above or below to get all positive powers. And then from that we saw, okay, 2's are together, we can multiply them, but this guy is an outlier. Let him stay with his family. Okay, the family of 3. So we moved this guy up and this power 2 became minus 2, which was the case here. We just moved once below and then we moved it back again for calculation purpose. Okay. Net, this is a family culture here also. When you're talking about exponents, same thing. The number of numbers with the same base, different power, they are part of the same family. You put them together, deal with them. Is it making sense or no? Sammy looks perplexed right now.
Yes, sir.
Everybody is okay? Tasvik okay? Sauria okay? Suhina?
Explain that again, please.
I'm sorry, you're done?
Can you explain that again, please?
Yeah, so what I was saying was, when you have a situation like this to deal with, your first attempt would be to get rid of the negative powers. So we learned, right? If I have a negative power, if I move from here to here, this will change to positive power. This again, I move below, it will become positive power. This guy can go up and becomes positive power. Here. When we came to this place, then we were thinking, how do I deal with them? Our exponent rule says that you can deal with the same family number of families. Not same number. Same numbers which belong to the same family. Numbers that belong to the same family. So this 2 power 4 and 2, this belongs to the same number family. But these two guys belong to the same family, right? You can move it up and then deal with them together. Okay? Applying an exponent rule. That's what I was saying. So when you move this guy up, this becomes minus 2. So you're multiplying 3 power 3 and 3 power minus 2. Rule of exponent says when you are multiplying two numbers with the same base, different powers, the powers get added. You added 3 and minus 2, you got 1. Doesn't matter. So at this point, we had the option of breaking it down and doing tic-tac-toe or apply the exponent rule for solving it. Yeah. Now it's time for me to go and take a fat nap. What I will do is, I'll give you guys one problem and go for the sleep. Okay, now I am not trying to So see, I'm also super excited about the upcoming holidays. So you will end up dealing with little more dad jokes today? Out of excitement? Let's see. So 5 to the power minus 7 into 5 to the power 4 into 3 to the power 9 divided by 3 to the power 7 into 5 to the power minus 2 into 2 to the power minus 8 into 2 to the power 7. Deal with it. 5 to the power minus 7 times 5 to the power 4 into 3 to the power 9 divided by 3 to the power 7 into 5 to the power minus 2 into 5 to the power, into 2 to the power minus 8 into 2 to the power 7. Time for me to go for. Now, I'm here with you guys, don't worry. My eyes are wide open, I'm not going to sleep. I want to enjoy how you struggle with this problem. So everybody is clear what we're trying to do, right? I'm asking you to simplify this. Applying our understanding of the negative exponents and the exponent rules that we have learned so far. Yeah? Sami okay? Abhi okay? Dikshita okay?
Yes, sir.
Hiranya okay? Gayatri? Tasvik? Mara, yeah, everybody okay? Sandra, Celine, Saria? Okay, I'm going on mute. You guys finish it and let me know. I'm assuming everybody is able to try. Yeah? Sanvita, sorry, you guys are giving it a try, right? Okay, good. Yes, Lach.
Can I see the answer?
Yep.
The answer is 9.
Answer is 9.
Yeah.
Okay. And if you have to explain that in exponent form, how much that would be?
When it's fully simplified with still exponents, it would be 3 to the power 2 times 2 to the power 1 over 5 to the power 1.
No, so you said your answer is 9, right? So if answer is 9, that will be 3 to the power 2 only, right?
Yeah.
Yeah? So just check whatever you got, because that's one habit I want to inject and force in all of you.
Wait,
What? Yeah.
everything to the power 0 equals 1, right?
Yep.
Oh, okay. So then that's not right.
Alright. So review your answer, okay? My only request to you guys is, when you have a problem that you're solving, solve it, you got the answer. I'll just keep few seconds extra with you to review or cross-check what you did. Yes, Lach.
Okay, so now I have my answer and it's 3 and 3/5.
Say it one more time.
3 and 3/5.
3 and 3/5. So
Yeah.
3 by 5. So
Yeah.
it's a mixed number you got.
Yeah, the
Yeah.
next number, yes.
Okay. How about you?
I'm done. I'm just trying to figure the last part out.
Okay. Let's see what everybody gets. So I have not confirmed, Lach, that your answer is correct. I would not do that on purpose. I want everybody to give it a try. Otherwise, everybody will get the same answer. And I myself don't know if that answer is correct or not, because without solving, how would I know? So you guys have, what happened to Adik and Arav? Very quiet today. Yes.
I'm confused on what was solved.
Okay, no, I'll come to it, beta. I'll explain that. Don't worry about it. Yes, Sammy, what did you get?
So I got 75 to the power of 6 over 60 to the power of 4.
Okay, how about you?
I got 3 and 3 fifths.
3 and 3 fifths. So 3, it's a mixed number, that's
3
what you're
and 3
saying?
over 5.
Okay, so 5 3 is 15 plus 3, 18 by 5. Is that what you got? Okay. We'll see. We will see. How about Abhi? Milana? What's up? What's going on right now?
I'm a little confused.
Little confused? Okay. So, I will anyways explain this after a couple of minutes. But in the meantime, I will suggest you guys to take a deep breath. Whoever is kind of struggling with it, take a deep breath. And ask yourself, is it actually difficult? Try it once after that, okay? While you are waiting for me. Yes, Tasvik.
My answer is 3. My answer is 3 by 5.
Okay, that's a mixed number you're saying? You got 5 3 is 18 plus 3, 21 by 5. Tasvik?
No, I got 18 by 5.
18 by 5. 5 3, 8, 3, yeah, 18 by 5, yeah, you're right. Sanvita, what did you get, beta?
I got 9 10.
You got 9 10th? Okay.
Yeah, so 9 over 10.
Okay. Okay. I'll probably give 2 more minutes. I want everybody to try because me solving it is one part of it. Obviously, my job is to explain things to you guys, but I certainly would want everybody to try once. Whatever you get is okay. Right or wrong doesn't matter. But trying is what is important. Aradhya, how about you, beta? Still working on it?
Yes.
Okay. How about Hiranya and Milana?
I'm still working on it.
Okay. How about Gayatri and Nihan?
I'm still starting to do it.
Okay. Salman and Sulaim, what's happening with her?
We're still working on it.
Okay. Yes, Abhi.
So
What is that, beta?
I need a leave.
You need to leave? Oh, okay. Okay. Not a problem. So good news is no class next week anyways, okay? So next Saturday and Sunday, no class. You guys will have fun and I'll have more fun. So that is on the occasion of Thanksgiving. So yeah, I thought I'll give you guys a break. I mean, I can still do a class on Saturday, but I thought I'll give you guys some relief from me. I've been torturing you guys non-stop for some time. Okay, so now let's see how I can do this with the concept that we have practiced so far or learned so far. Everybody here, my steps are very predictable in nature, very predictable, except my dance steps. Okay, those are unpredictable because I don't know how to dance. So my dance steps are unpredictable, but my mathematical steps are very predictable. Let's look at it here. Everybody here. Myra.
Oh, we have to go now.
Yeah, go ahead.
Can I
Just,
state
yeah.
explanation?
Next 2 minutes, okay?
Yeah.
Okay, now look at it. My steps are very predictable, I said. When I have a negative numbers, I don't feel comfortable. I move them in a direction so that it becomes positive. So this 5 to the power 7, I can move downward and that becomes 5 to the power 7. This guy is done. 5 to the power 4 is here. Positive number, I'll not touch that guy. 3 to the power 9 remains here. That's okay. 3 to the power 7 remains here. 5 to the power minus 2, I move this guy up and that becomes 5 to the power 2 plus 2. Then 2 to the power minus 8, again I move it up, that becomes a positive power. Then I have 2 to the power 7. Now look at it. You have here 5 to the power 4 into 5 to the power 2. When you multiply two exponents with the same base, the power gets added. So it becomes 5 to the power 4 plus 2, 6. So this number and this number taken care. Now 3 to the power 9, let it be here. 2 to the power 8, let it be here. Divided by 5 to the power 7 into 3 to the power 7 into 2 to the power 7. Now deal with the numbers from the same family. 5 to the power 6, 5 to the power 7. 3 to the power 9, 3 to the power 7 together. This and this together. 5 to the power 6 divided by 5 to the power 7. When you divide the exponents, it becomes something power a minus b. 5 to the power 6 minus 7. This is the first one. Then 3 to the power 9 divided by 3 to the power 7. Again, 3 to the power 9 minus 7. Second rule of exponent. 2 to the power 8 divided by 2 to the power 7. Second rule of exponent. 2 to the power 8 minus 7. What did you get? 5 to the power 6 minus 7, that is 5 to the power minus 1. Into 3 to the power 9 minus 7, that is 3 to the power 2. Into 2 to the power 8 minus 7, that is 2. So now what you have is 5 to the power minus 1 into 3 to the power 2 into 2. 5 to the power minus 1 will become, it will move down and become 5 to the power 1. And then this is 2, sorry. 3 to the power 2 is 3 into 3, 9 into 2, 18 divided by 5. So that is how it became 5, 3 over 5. Does it make sense to everybody, or I was just rushing through it? If you look at the whole journey, we have this number. My first step, as I said, is predictable, meaning all the negative numbers I will move, negative powers I will move down so that we can get rid of that. So we moved this guy down, became positive powers. This is positive, we kept it here. This is positive, we kept it here. Then we came here, 3 to the power 7, positive power, we kept it. This one is minus 2, we moved it up, became positive power. Minus 8, moved it up, became positive power. And negative power, as this power is positive, so we kept it here. So from this one, we saw, okay, in the numerator I have two numbers with base, same base. We applied the first rule of exponent, multiplied them, powers got added. That became 5 to the power 4 plus 2, these two numbers. This is one number, we kept it as is. This is another number, we kept it as is. Denominator, we have 5 to the power 7, 3 to the power 7, 2 to the power 7 as well. So we dealt with these numbers together, these numbers together, these numbers together, from the same family. And here we are talking about second rule of exponent. Yes, better.
So whenever it's a negative number, the negative numbers go on the bottom of the positive number.
Yeah, you just move this whole number below and the power changes from negative to positive or positive to negative. So if you had a plus 7 here and if you would have moved that here, that would have become 5 to the power minus 7. That's it.
Yeah.
Is that clear to everybody? Hiranya, Milana, Aradhya, Shahina, Nihan, Raj, everybody okay? Alright. So I know, yeah. So I know this is what we had in the agenda today. We just want to talk about negative exponents, and it is a very short topic if we are clear about what are the rules of exponents when it comes to multiplication or division. And by applying that, one thing that we learn, I mean, if you look at what we have done so far, there's only one small thing that is coming into picture. That is, if you have any number to the power to negative power, you can just move it from numerator to denominator. The power changes from positive to negative or negative to positive. or vice versa. If you have any number to the power negative or positive in the denominator, if you move it up, meaning if you take it from numerator to denominator, from denominator to numerator, again the same thing will happen, but power will change its sign. Yeah? Advi, Karav, are you okay? Saurya, Sandrine, Celine, okay? Hiranya, okay? Adya, okay? Okay. Sami, Suhina, everybody fine? So here's my gift to you guys for the Thanksgiving. So thank you so much, each one of you, for trusting me as a teacher. Yeah? Without you guys believing in your teacher, I'm not relevant because I'm not a qualified teacher at all. I have been a student all through, and whatever I had learned during my childhood days, that's what I'm trying to pass on back to you guys in a more conceptual way. So thank you so much for being part of the class, bearing with me. Sometimes I get super mad. You guys are still tolerating me. Sometimes I mess up with my approach. You guys are showing the patience to learn from it. So again, patience works as a trick for us, and we'll continue with our journey of learning things. But the gift here is, I will give you guys 1 week of freedom from next weekend. We'll not have a class, so that you guys can spend quiet time with family and friends. Still make sure that you guys stay safe. But the bad news is I'll still give assignment, and my assignments are not overwhelming. So I would assume that you guys will find out a small time window to solve those things, do the assignment, and before we meet in the class in the first week of December. Okay. In the meantime, if somebody gets super worried about any particular problem, something that is haunting you so much, and you still need a clarification, let me know. It's okay with us. Sometimes you have to have free time to unwind yourself. Okay, that's how I would look at it. I mean, I'm super excited for the class whenever I meet with you guys, right? I mean, I'm too old to do math for myself, but you guys are my opportunity to go back to my childhood and then redo the things that I've done 35 years ago, right? So I'm always happy, excited to meet you guys. 2 reasons, right? I mean, you guys are all like my own kids. That's how I treat you all, and I'll continue doing that. But at the same time, it gives me a chance to deal with the subject that I like the most all through so far. So I know it might be a bit of break, but take it with a pinch of salt. It's okay. Let's use the time to spend time with family and unwind ourselves, and take the maximum out of the Thanksgiving break. Go for the shopping, all the percentage concepts that we have learned and practiced. This might be the time to apply that. Yeah. So with that being said, I'll let you guys go. Little early. Whatever we learned today, I hope that comes out handy for you all, and we'll keep doing more fun with math going forward. Yep. Any questions, any concerns, anything that you want to share before we break? No?